Sound. There we go. There we go. There we go. Okay. Where were we? So yesterday, this is unfortunate. That I can't get the YouTube streaming working. Um, all right, let me send out. Okay. So, problem we saw yesterday is I'm suspicious about this bridge here. And how D plus and D minus have some ridiculously low, like 3.2 ohms resistance to ground. That doesn't seem right. So I'm thinking of trying to remove um, D8 and D11. These two Zener diodes designed for surge protection from this to see whether or not those parts are busted. But before I do that, I want to check a USB circuit that is working and see what is the typical grounding for a USB circuit. So I want to find a USB device that I can check the behavior of. Maybe unpowered. Just to see whether it's typical in a UART to have the device have its data pins be surrounded. So let me grab this tiny Pico. Whoops. All right, and let's check this. got the tiny Pico here. All right, so those are the USB, the data pins, and all right. Let's see. So I've got ground here. Right, and so that's virtually 0 ohms. All right, so ground to ground. Okay, so what is what here? Oh, what? Let me try a different one. Yes. Probably should use one that's known to be working. So I think what I'm seeing here is a little better. What I'm seeing here, unpowered circuit is that's ground. That's ground. Plus here has like 5 to 6 mega ohms changing, right? So, but there's some semiconductor action here, but some large amount of resistance on plus, and then a very tiny amount of resistance on minus. Right, if I look at 5 volt here, okay, so that's okay. So for ground, at least, it's like varying resistance on plus side, and then very little on D minus. Some other device check. What is this? Do we know light? check this. That's some. All right, there we go. All right, so very little, 0.5 ohms, basically along that ground.
W_General said, "Do you know what the DDX-RX?"
All right, so here I've got high resistance on all of the leads but ground. All right, so let me just double check. Put this away. For a moment, and then just figure out. Yeah, so yesterday I bought this used on eBay, or I bought this used on eBay like a week ago, and one deck B was broken. That turned out to be someone had gone in and unplugged a bunch of the internal cables, plugged them back in. Deck B was working fine, and then I went into service mode, double checked everything. Everything's fine with all the buttons and the lights and everything. Now the problem is USB does not work. The 5-volt lines come in. So when I plug the USB in, the controller reacts when it sees 5-volt power and flashes lights. That works, but it doesn't actually present as a device. It's like the data pins don't work. Looking at the schematic, there's got to be something busted. There's no cables and stuff in between the USB and this TUSB 3200C. So this TUSB 3200C, you probably can't see very clearly the schematic and on the stream, but essentially there's that big block here, IC21, is this Texas Instruments USB streaming controller. And so this controller is all-in-one, presents itself as an audio class device. And then it's essentially directly connected to the USB port, which is the block to the left. So there can't be anything really simple to fix in between these if it's not working, because really, it's really straightforward. There's not a lot of components here between the jack and the IC that acts as the class device. And so it's got to be either the IC is busted, and there's just some really vague, like bad English instructions on checking this. It's like, check whether USB communication line is fixed at H or L, which I'm not sure what this means. USB communication line is fixed at H or L. I can probe between like D plus and D minus on the USB and ground, and it's at 0 volts. Does that count as USB communication line fixed at L? I guess. Check whether the MRST signal of IC21 is fixed at high. And yes, the MRST, which is IC21 pin 10, pin 10 of this IC here, it's at 3.3 volts constantly. I guess that counts as fixed as H. And then the last and the most mysterious piece of the diagnostic flowchart is, does not the part on the USB line have the abnormality? part D8 to D11, L16. Right? So D8 through D11 are these surge protection blocks. These are each one of these is essentially two Zener diodes pointed at each other. And so I guess if the voltage goes over, looking this up in the data sheet, the voltage goes over some amount, right, 6 point something volts, then the Zener diodes, they should open up in either direction, and the current will flow directly to ground instead of flowing through your device. And there's 4 of these. They're both connected to the data pins, to the USB D plus and D minus. It's just that 2 of them connect D plus and D minus directly to ground, and the other 2 connect D plus and D minus to ground through some capacitors. And the weird thing here, again, you probably so the weird thing here is normally I would expect to see some filter caps on this line for D plus and D minus. Well, actually, no, you wouldn't have filter caps on D plus. Well, they're in the reference architecture, or the reference in the evaluation board for this TUSB 3200. In the schematic for that, there are some capacitors that connect D plus and D minus to ground. They don't have those. Instead, they have this L16, this filter inductor that I don't fully understand, because none of the other USB circuits that I have put an inductor in line with the data pins. I can't find any other device I have that, or other schematics that have this. But I presume this is supposed to work. So there's some kind of filter inductor here on the data lines leading in, and then there's this thing that goes in this PUR port. This part here with the 222 ohm resistors and the 1.5K. This is part of the reference architecture. So whatever this part is, and I didn't read the data sheet for this TUSB 3200 very carefully, as necessary. This part out here, this all seems to be some kind of protection circuitry. And so I've got 8 and 11 that take D plus and D minus directly to ground, and then 9 and 10, which go through 2 capacitors, and then is connected to this MPZ 2012 S1. I don't know what this thing is. Well, I guess it's L15, so it must be another inductor. I'm not exactly sure. And then also go to ground. These 2, 9 and 10, go to ground through a bunch of capacitors. And what I can tell is that D minus and D plus, no matter what, whether the device is on or off, and whether this is connected to my computer or not, are always at 0 volts. They're always pulled to ground. And the resistance between D minus and D plus and ground is extremely low. It's like 3.2 ohms consistently. And I'm not sure why that is. At first I thought, well, maybe, there's some connection. Maybe this IC is weird. But now I'm suspecting that D8 and D11, that these guys are busted. Because when I look at D9 and D10, and I measure current from the data point to the other side, right? So not including the resistors, basically from D plus to the other side of D9, or D minus and the other side of D10, there's significant resistance at those 2 points, right? Now, of course, I don't know what direction I'm measuring them, right? Because when I say I'm measuring D plus, right, it could be this is the resistance from any point along this line. But there's something like 300 something kilo ohms between these 2 points, and then on the other side, if I measure from D plus to the other side of D8, or D minus to the other side of D11, there's like 3.2 ohms, really small. So I suspect maybe D8 and D11 got blown out by something. But I should be able to check because this is protection. Like, I can just take these two out and I can see if the circuit works, I think. That's the theory, right? For me to validate whether or not it's D8 and D11 are busted. L16, this thing is weird. I don't know how to determine whether or not L16 is working or not. That's beyond my knowledge. I'd have to do some research to figure out why this is this just an inductor array, the ACM 2012, or do these two inductors interact somehow? I have no idea. This is kind of an exotic part for me. But what I was just doing is checking a couple of other USB devices I had just to see whether or not it's normal for D plus and D minus to have low resistance to ground, maybe through the chip. And that does not seem to be the case. Both on like, actually, they're both Arduinos. They just essentially have two, things with UARTs. There is high resistance, at least between D plus and ground. D minus seems to sometimes have low resistance to ground on one of the devices I have, and it has high resistance to ground on an unpowered circuit for another device. So that's what I'm going to do now. I'm going to try to take out D8 and D11, which are, let's see, I hope. I think the problem is I won the encoder lottery on Twitch, which unfortunately means that I'm getting throttled down to 720p. It's not showing the 4K signal. My YouTube is busted for whatever reason. I cannot get YouTube Live to work. D11, D8 and D11 are these two components closest to the USB. And what I'm going to do is take them out and see what happens. Oops. All right, power save on the fluke. And this guy's a little on the big side for my workbench. It pretty much takes up all my available space. So workbench is a little cramped. And of course, if anyone in the peanut gallery, especially anyone who might actually be an electrical engineer, if there's a flaw in this plan, let me know. Right. Let's see. So what I need to do is I need to grab this component here while heating up in hot air. And almost certainly this is terrible to work with lead-free solder. So I'm going to need a lot of heat. Let's go 300C on the rework gun. Great. I'm going to knock The cable on this is going to knock over a bunch of screws. There we go. All right. And then I got to not unseat any of these other devices. So let me. Got to be careful not to knock anything else here. Wait, you have a reasonably good view. Super easy to tell whether or not the solder is released. Ow. Whoa. All right. Oh, dear. That's not a good sign. Oh, it's going to be super hard. This chassis is real hot, and that's a bad sign because that means that there's some like huge ground plane or something soaking up heat. Or something soaking up heat. This should not be taking this long. All right, there's one. I'm going to put it here. Let go. All right. Scared of using too much force, not because I'm afraid of breaking the component, but I'm afraid of knocking one of these other components out. This heat gun's pretty hot. There we go. Ah, damn it. All right. Oh no. I moved D9. All right, now I got to put D9 back. I mean, that is super hard to get D9 back in place. Ow! Ow! All right, let's try this differently. Let me try to move D9 back in place. Which is not super easy because I can't easily move D9 precisely with my left hand. Okay. Now let's see if I can. Oh, God damn it. D9 is gone. It got blown away. I don't think D9 and D10 are necessary anyway. But, alright, I gotta find out where they went. When I laid down one of these guys, I knocked the other one off this ribbon cable, and then I blew D9 away. And I'm not sure where it went. Okay. That was annoying. That was annoying. And I'm not sure how. All right, that was annoying. Okay. And I want to keep these separate. Oh, here's one. I think this is D9. Because if my hypothesis is correct, D8 and D11, and that D8 and D11 are blown, and D9 and D10 are fine, I can compare the behavior, at least the resistance, across these two and see if they're any different. Where? I'm actually not too worried about replacing these. I actually already ordered replacements for these from DigiKey. Because I can clean up the pads with solder wick and use leaded solder with a sticky flux to put these back on. Using low temperature paste. Where? Okay. Now let's probe. Now, all right. So that was definitely because now with those removed, the data pins are like 7.48 mega ohms to ground and like 7.1. Okay, so there's way more resistance to ground now that I removed the Zener diode, the diode array. Now, can I probe this? Oh my god. Probe these tiny specks. This thing is pretty difficult. .8 ohms. Yeah, I'm pretty sure that that's not right. This is two diodes, Zener diodes pointed at each other. The resistance should be higher than 3.8 ohms. Let's check what this one looks like. 8 mega ohms. That's more what I would expect from two diodes pointed at each other. All right. Okay. Now let me listen to my computer. My device manager. All right, let's see what is. I can plug this guy in. Oh. Oh, that's a good sign. I did not get that before. Pioneer DDX-RX. Yes, okay. Whew. All right. That was the problem. Too blown out. Too blown out. Surge protection things in really tiny packages. Okay. Good. Well, I feel that was a major accomplishment. Nice. I've never been so satisfied by hearing the Windows device connection sound. All right. Well, I can't do anything more on this until the replacement parts arrive. Fortunately, the schematic is well documented. So this is definitely an RSB 6.8S that I need. I've got 4 on the way from DigiKey. What I will do now is I think I'll clean up those pads. I'm going to clean up those pads. So let me flux down those pads and then flux down those pads and then hit them with some solder wick. So this thing must have taken a surge. So if I were to guess, this thing took a surge, and then someone went in and tried to fix it, couldn't identify the problem, put it back together, and put it back together incorrectly, such that when whoever next figured out what was the problem, they're like, oh, deck B is busted. But actually, it's that USB is busted. All right, let me attempt to. Up these pads a bit without burning myself and without messing up D10. Come on. Come on, D9 cleaned up so nicely. Why can I not get this off of D10? Or not D10, D8. Come on, D8. That pad is going to be trouble. That pad on D8 must be connected to ground. Yeah, and it on this massive ground plane. So it's real hard to get that one pad hot. Somehow it's better connected, thermally better connected to ground. Oh, I see, because there's this huge ground plane here. And then D8 is right in it. So that's why this part here got so hot. Whereas on D11, the ground plane here is much smaller. So this one pad here on D8 must have been why I had so much trouble getting it off. And I'm having a lot of trouble sucking up the solder with the solder wick off of that pad too. All right, I think that's as good as it's going to get. Fortunately, the stuff that I'm going to use is low temperature. Extra low temperature. Melts at like 138 C. Clean up this. Then that's all I can do. I'll have to move this away somewhere until the replacement parts get here. Yuck. All right, that's not too bad. That's it. Didn't even take an hour. But the exciting final fix, probably not until next week.